Welcome to today's lesson. In our previous classes, we learned that solid materials expand when heated. Now, we are moving into a fascinating phase of thermal physics, the thermal expansion of liquids. Now, here is a fundamental fact you must remember. Just like solids, liquids expand when their temperature increases. But there is a catch. Liquids actually expand significantly more than solids for the same rise in temperature. Why does this happen? Think about the particles. In a solid, the particles are rigidly bound together in a fixed lattice. But in a liquid, the particles are not as rigidly held. They have more freedom to move, meaning that when you supply thermal energy, they push apart much more easily, resulting in a greater overall expansion. To prove this to the scientific world, we need a rigorous experiment. Let's head to the laboratory setup. Let's construct our experiment. Imagine a glass flask completely filled with a colored liquid. Sealed tightly at the top of the flask is a narrow, transparent capillary tube. Because the flask is full, the liquid naturally rises up into this tiny tube to a specific starting position. Let's label this starting level as level A. We take this entire apparatus and place it inside a heated water bath. Before the heat begins to change anything, our liquid rests perfectly still at level A. Watch this initial state closely, because what happens next completely defies intuition. As the water bath heats up, something unexpected happens. If you watch the capillary tube, you will notice that the liquid level suddenly drops from our initial level A down to a lower position. Let's call it level B. This can cause immense confusion. If heating causes expansion, why did the liquid level drop? Does heat make liquids contract? The answer is a beautiful lesson in heat transfer. Remember, the heat must travel from the outside water bath through the solid glass wall of the flask before it can ever reach the liquid inside. Because the solid glass container receives the heat first, the container expands first. When the flask expands, its internal volume increases. The liquid has not received any heat yet, so it stays the same volume and drops down to level B to fill the extra space newly created by the expanding glass container. But wait, keep watching the apparatus. As time ticks on, the thermal energy finally penetrates through the glass walls and floods into the liquid itself. Now, the liquid begins to heat up rapidly. And remember our core fact from the beginning of the lesson. Liquids expand much faster and much more than solids. Because the liquid's rate of expansion completely overpowers the expansion of the glass, the liquid level at position B stops falling, reverses direction, and begins to shoot rapidly upward. It rises past level B, surges past the initial level A, and climbs all the way up to a brand new peak, level C. This dramatic rise to level C definitively proves two things. One, liquids absolutely expand when heated, and two, liquids expand far more than solids. This profound laboratory observation introduces a critical challenge in thermal physics. When we look at the total movement from the lowest drop, level B, all the way to the highest peak, level C, that represents the real absolute expansion of the liquid. But if we only look from our starting point, level A, to the final point, level C, we are only seeing the apparent expansion because the expansion of the flask masked the true values. Therefore, when we measure the cubic expansivity of liquids in our upcoming lessons, it won't be a simple, straightforward measurement. We must always mathematically account for the expansion of the container. Thank you for watching this practical lesson. Make sure to follow the Udimking Education Foundation on our WhatsApp channel and social media platforms for the upcoming mathematical breakdown of real and apparent expansivity. See you in the next class.
Udimking Education Foundation. Building confidence, ending examination malpractice for a better tomorrow.
We are building a better tomorrow.
Join us in shaping futures through integrity and education.